Well, good morning, good afternoon, or in the case of some people, I think it's like really early in your morning or very late at night, depending how you look at it, since it seems that we have people from Mexico even. I just wanted to welcome you to this online session. We're talking today about how to design, construct, and operate CSP towers with molten salt storage. For those who are very familiar with the technology, I've seen some names. Hello, Giuseppe. And also people who are new to the technology, perhaps. Let me give you a little bit of context on how and why towers. So there is two different kinds of CSP or concentrated solar power technology. Main technologies. There are more, but there were two ones that are most commercially deployed are parabolic troughs and then tower. In the case of tower, they're usually what is understood is that the efficiency is higher, the temperatures are higher, and has a number of technical advantages that Manuel and Johnny are going to tell us about. But it also has, of course, the issue that is a little bit more complicated, and there is not as much deployment as parabolic troughs, so there is less people who understand how to build them, design them very well, even though it's a technology that has been deployed like quite widely since like the 70s, if I'm right, with Solar 1 and Solar 2. Still, with the fact that there is not that much deployment, so we're learning slowly but surely. And today, I mean, we already have towers that are operating more than 150 megawatts per tower. So this is what we're going to be talking about here today. And I can see here that there are people who could lecture us all, about towers. Welcome, Ignacio. So I'd like to ask our experts for today to introduce themselves. Manuel, can I ask you first, let me take your microphone, your mute off. Could you introduce yourself shortly and your company?
Yes, of course. Hello, everybody. My name is Manuel Smoldas, and I'm technical expert of the concentrated solar power business line from the energy sector of the company called John Cockerill. And I'm in charge of the technical aspects of the solar business line and managing the R&D. I've been working for John Cockerill since about 10 years. I was first involved in industrial boilers, and now I moved a few years ago in solar technology.
Thank you very much, Manuel. I'd like to ask now, Johnny, I'm going to mute your microphone. If you could please introduce yourself.
Okay, hello, everybody. I'm Johnny Liu from the Subcon Solar, a tower CSP technology provider. I'm the director of overseas business development, just in charge of all the overseas projects. And yes, I'm very happy, to be here and talk to everybody.
Thank you very much, Johnny. I see also we have Manuel Blanco with us. So we have like heavy weights in the industry, guys. No pressure. You got a lot of pressure right now. So whilst I explain the session, Manuel, why don't you share your screen? And we can, and I'll explain how this is going to work. And welcome everyone. It's really good to see people from wide. We have people from Australia, we have people from Mexico. They can't be like the times of day. They're completely different. And we have a lot of people from India, from Germany, a lot of people from Spain, of course. France. I've seen a little bit of everything, in Nigeria. So welcome everyone, and thank you for being here. Manuel is going to give a presentation, John is going to give a presentation, then we'll take questions. Both of them have worked extensively with towers, and as of late, in the latest developments, so they would have information probably that will be useful to everyone. But please just feel free to use not the chat. The chat we actually use for comments and things, but the Q&A, which has like a nice list that we can manage for your questions, and we'll take them after the presentations are over. Just a reminder, we are recording the session. We will send you the recordings and we will send you the materials, okay? Manuel, without further ado, let me take your microphone off and off you go.
Okay, perfect, thank you. So before to go ahead with the design of our solar receiver, I would like to just to present John Cockerill in a few slides. So the story of John Cockerill started about 200 years ago. This is a quite old company. The products were different, but the philosophy remained the same, to provide answer to the needs of our time. So preserving natural resources, contributing to greener mobility, producing sustainably, fighting against insecurity, and facilitating access to renewable energy. And an interesting fact to mention about the company is that the founder, John Cockerill, has been a pioneer in steam production and actually launched the industrial revolution in Europe. So our contribution to business, government, and communities consists of services and associated equipment for the sector of energy, defense, industry, the environment, transport, and infrastructure. And we are about 6,000 employees, and we achieved a turnover about 1.3 billion in 23 countries and 5 continents. So about the energy sector, as mentioned before, the production of steam is a long story for John Cockerill. Since decades, we design, manufacture industrial boilers and recovery steam generator for combined cycle power plants. So historically, this is it. And based on this strong expertise in steam production, pressure parts, thermal efficiency, and so on, we developed 2 generations of thermosolar receiver. First, the direct steam generation, and after that, the molten salt solar receiver. And finally, I mentioned that we are also active in storage of energy and in production, storage, and distribution of renewable hydrogen. So let's talk about the solar receiver. Since its creation in 2011, John Cockerill Solar developed and provides central receiver and other components of for high power concentrated solar power station. So first, we have designed and provided the solar receiver from the power plant of Key Solar 1, 50 megawatt. This is a plant currently in operation in South Africa, and it was the first generation of solar receiver able to produce high pressure superheated steam. Then, because of the need to reach a long duration storage and be able to produce electricity 24/7, our team has developed and provided a molten salt solar receiver to equip the solar plant Cerro Dominador in Chile, 110 megawatts. This project has been delayed and restarted recently. We are not reaching the end of the construction phase. At the end of the year 2017, John Cockerill Solar got a contract for a molten salt solar receiver in the frame of Luneng Haishi project, 50 megawatt. So this is a receiver currently in commissioning phase. And more recently, at the end of 2018, we have been awarded for the supply of the receiver of Diwa project in Dubai, 100 megawatt. And this receiver is almost ready to be lifted at the top of the tower. So, but better than a long speech, here are a few pictures from our project in China, so the Haishi project, 50 megawatt. And if you have a look at the top of the tower, you will have a great view of our solar receiver. Apart from this equipment, John Cockerill is also designing and providing molten salt steam generator. And this product has been developed taking into account mainly 2 features. First, we use internal ball welding for the connection between the tubes and the tube sheet instead of expanded tubes to improve the configuration in terms of fatigue, avoid crevice corrosion, get a leakage-free design. And then we have an original helical baffle we use to decrease the pressure drops and get a fouling-free heat exchanger. But let's go back to the MSR, the solar receiver. Already for the first generation, our direct steam generation solar receiver had to face to high level of strain, high level of stress, then night cycles, huge gradient, and so on. And when the market demand evolved, mainly to increase the storage capacity, as mentioned before, from direct steam generation to molten salt CSP power plant, we had to add freezing, because the salt freeze below 240 degrees, corrosion, and other specific risk to the list. So first, John Cockerill was a boiler provider, and based on this experience, and after 10 years of development, we began an independent solar receiver provider. So basically, we can work with every heliostat provider and set up our solar receiver on every tower. It gives us the agility required to provide, well, the best answer to every challenge listed on the previous slide. So to do so, we have defined several design criteria to optimize the flexibility, the reliability, and the operation cost of our equipment. So in terms of flexibility, we have taken into account the frequent startup and shutdown, the wide range of operation between 20 and 100%, and the flux and temperature ramp in our design and in our lifetime analysis. The reliability of our equipment is ensured by, of course, an adequate material selection and the use of John Cochrane monitoring system by infrared camera. I have a slide about that later. And finally, the optimal choice for limitation. And about this limitation, they have to be chosen as accurately as possible, without margin, to be sure that the solar receiver integrity is in one end is ensured, and in the other end to optimize the performances of the plant. And last but not least, the pressure drops and the accessibility are also key parameters in the design of our equipment to minimize operating costs. To take into account these design criteria, actually they are integrated in a John Cochrane software suite made up of 3 software called Solar Receiver Design, Solar Receiver Simulator, and Solar Receiver Monitoring. So a few words about these 3 software we use to take care of the design. The Solar Receiver Design software is a steady-state thermodynamic model. We use it mainly during proposal stage to optimize and guarantee the performances of the solar receiver based on different flux maps. The main input will be the flux map coming from the heliostat provider. It allows us to validate the receiver dimension to check the internal design criteria, such as the salt velocity or the internal metal temperature, which has to be limited to avoid corrosion, and well, a lot of other internal criteria. The second software is a solar receiver simulator. We use this dynamic model in the frame of a project to check the solar receiver response to external dynamic solicitation. So for example, when a cloud appears or when a pump trip occurs, this tool calculates the evolution of the tank level, the pressure, the temperature everywhere in the receiver. So this is truly a tool, let's say, to predict the future and simulate the dynamic behavior of the solar receiver. And finally, the solar receiver monitoring software is set up on site to be sure the solar receiver works below the limits in operation. So this software, of course, is also very useful to extract data and analyze it to learn lessons. Before to wrap up, I would like to make a focus on several very important aspects on which John Cochrane pay particular attention to guarantee the receiver lifetime and the performances, which are very important points. Since the beginning, the understanding of the corrosion behavior has been highlighted as a key factor to increase the performances of a molten salt CSP plant. Indeed, I was talking about limitation. If the metal temperature limitation could be increased, the performance will increase also. So we decided to launch a corrosion test campaign to optimize this limitation. And this molten salt test loop will be in operation in summer and will allow us to simulate the solar flux, the day and night cycle, and the erosion induced by the flow, etc. Apart from corrosion, the loop will be also used to optimize the heat exchange and perform additional campaign to prepare the future with new fluids, new materials, etc. And the second point illustrated on this slide is the constitutive model of the materials we have built based on different mechanical tests. Thanks to a sophisticated thermomechanical model and this constitutive model, we are able to evaluate accurately the specific lifetime of our solar receiver in the frame of each project. Another important aspect regarding performances is the absorber coating John Cochrane has developed. The Cochrane 750 makes our solar receiver more efficient and don't require any curing after application. And it will reduce maintenance operation on site, leading to increase the availability of the electricity production of the plant. Several solar absorber coatings were tested and compared by the DLR in PSA at different test conditions. I've seen on the list that we have some guy from DLR, so hello to them. And well, they have judged that the Cochrane 750 from John Cochrane was very stable and reaches the highest solar absorbance in the Cochrane coating tested. Finally, I mentioned that we have done hundreds of simulations to analyze the preheating before filling, the salt freezing, the hydraulic in the solar receiver, the filling itself, the drainage, the thermomechanical behavior of the tube, the thermal losses, etc., etc. And we do not hesitate to perform tests in lab, such as in a wind tunnel, to calibrate and improve the accuracy of our simulation. So, in conclusion, based on 200 years of experience and to deal with a lot of challenges, John Crockrell has defined key parameters and design criteria. And they have been implemented in our tree software to take care of the solar receiver during proposal, project, and operation. And we actually feed our model and perform day-to-day improvement to our design criteria thanks to the lesson learned, test results, simulation, etc. Thank you very much for your attention. Don't hesitate if you have any question.
Thank you very much, Manuel. If you can take, please, your screen off so that Johnny can share his. Just at the top, or maybe I can help you. Okay, Johnny, share your screen. Let me take your microphone off mute. And I'd just like to also take opportunity whilst, Johnny is putting his presentation up to thank our sponsors for this webinar, as SQM, provider of natural solar salts, and Siemens. You all know Siemens. And we want to thank them because it's thanks to their support that we are able to create content like this ongoingly. So, thank you very much for that. And for anyone who is interested in participating in this supporting, just get in touch with us. Johnny? Go ahead, and
I think you can see my screen, right?
We can indeed, yeah, perfect.
Okay. So I'm Johnny from Subcon Solar. I'm going to share our practice and experience in the CSP industry. There are three parts. The first part, I'm going to introduce Subcon Solar quickly. Yeah, our company is one enterprise focused on the tower CSP technology. We were founded in 2010. We have three backgrounds. One is the Subcon group. Subcon group was created by one of the top universities in China called Zhejiang University in 1990s. And we also have another two shareholders. One is Hangzhou Boiler, one is Hangzhou Steam Turbine. We can provide the receiver and the turbine equipment and to make a whole package for the CSP technology. Subcon Solar, since the foundation, we have dedicated in the tower CSP technology. Now we have 202 patents covering the technology in the solar field and some more storage and the software for the CSP plant. And our main business model is a technology provider and equipment provider. And we also can do the development, invest, construct, and operate the CSP plants. We have four main project reference. One called the Delingha 10 megawatts. This project has 3 years operation. And in the very beginning, it's a steam receiver. And we changed it in 2016 to molten salt. Now it has run for 3 years with nice performance. And the second one called the Delingha 50 megawatts. It's a molten salt tower CSP. It's synchronized in December 2018. Now has 7 months commercial operation. And the third one is called the Gonghe 50 megawatt project. And this project is owned by company called Power China. It's synchronized in September 2019. For the first two projects, SUPCON Solar is the owner and the developer. And also we did the EPC and operation for these two projects. For the Gonghe 50 megawatt project, we provide our technology and equipment to Power China. The third one is called the Meinos 50 megawatt project. This project is in the progress of finance closing. We are a member of the EPC together with a company called the CGGC, not Chinese state-owned company. And this project is to be the first CSP in Greece, and we'll use the technology and equipment from SUPCON Solar. So in my presentation, I will to introduce our Delingha 50 megawatts project, and also to share a little bit with the design and the construction and operation about this project. This project is located in Qinghai province in the west part of China. The DNI is around 2,000. And this project is equipped with 7 hours storage by molten salts. And with 542,000 square meter heliostat and around 10,000 tons the salt. And every year it's designed to generate 146 gigawatt hour. I will show some pictures of this project. And yeah, this is the heliostat and the receiver, and it's our product. It's a picture from the top. This project, actually the site activity started in 2017 and in March, and we synchronized this project in December 2018. The construction period is 18 months. I want to explain. There are 3 months in the winter time in China. We can't do the construction, so the totally construction period is 18 months, and it's a record, and we constructed very fast. And this project is formally put in COD since September 2019. This project is running very nicely. All the design value has been reached. The capacity designed 50 megawatts, and the maximum it can reach 52 megawatts. And the minimum load can go to 7.5 megawatts, 15% of the capacity. And the thermal storage, the molten salt temperature, the steam and the parameter, and all the conservation rates has been fully reached. And in this slide, I would like to highlight the operation performance of this project. This slide shows the operation data from the first half year since it put in COD. It's increased very quickly, and the average electricity production reached to 97% of the performance model in the first half year. And the last 3 months, it's over 100%. And we expect to reach 100% in the first year after COD. I think the running condition is very good, and this the performance is really nice compared to all the plants in the industry. The next part, I would like to share some experience about the design and construction of this project. Speaking of design, from the development and feasibility study stage, we have to select a site with good solar resource and geotechnical, hydrological, and wind characteristics. This is very important to have a good place to construct the plant, and also the plant has to have sufficient land with a good topography, and it's close to the grid, consumer, transportation, water supply. It's also very helpful to have very good conditions. And for the conceptual design stage, SUBCON Solar has developed our own CSP design platform, and we can do a different configuration of the systems, and to define the size of the solar field, the tower height, the small storage turbine, and to get optimum production and the lowest LCOE. And for the basic and detailed design stage, this project, we have some special design. And the heliostat is customized because the weather in the Delingha area is very harsh. It's in the winter, it's very, very cold. It's -35, and also it's 3,000 meters high. And so we made some special design for the heliostat to stand the weather. And also that place is very cloudy, so the receiver every day has the temperature change frequently. So we made a flexible structure for the receiver design. And for the tanks, also it's creative, and we use ceramicite-based composite insulation foundation of the tanks to reduce the loss of the thermal, and also have enough support for the tanks. And for the SGS, it's also a very new design. It's with 2 parallel passes to increase the availability of SGS, and also can ramp up and to work together with the turbine to ramp up and ramp down very quickly. And for the heat treating, we use the fault tolerance and to increase the availability, because in that area it's very cold, so the heat treating system is very important. For the construction, as I said, it's we used 18 months to finish the construction, and we monitor the construction activity very closely, and also established some standards for the key equipment and the pipes for the molten salt tank, the receiver, electricity heating system, or the mobile devices, also the welding of the pipes. We have the specific methodology to do the construction. The third part, I would like to share some experience about the O&M. For the Delingha 50 megawatt project, we operate by ourselves. Actually, before the COD, normally 6 months to 12 months, the operation team is there on the site to do the mobilization for this project and to set up all the procedures and for the operation. And we have SuperCon Solar has developed several operation tools to support the operation of these plants. And I would like to introduce some. The first one is the automation, automatic control system. And SuperCon has a very strong background from the automation and the control industry. And the heliostat field control system is developed by us. It can support more than 100,000 heliostats with high accuracy. And this heliostat control, this field control system has some good points, and one is the machine vision technology based heliostat division detection. The name is very long. Actually, it's it can do the auto calibration, and also can have a self-learning function. And this system also can diagnose the problems of the system and to improve by itself. And it can work with the receiver control system to monitor the temperature and to adjust the solar field. The next one is about the cloudy forecast system. We developed this system based on the imaging processing and meteorological big data. And it can have a good energy flux control of the receiver, especially under the cloudy conditions. And also can just curtail the thermal shock of the receiver within the design criteria. SuperCon Solar also manufacture and provide the cleaning machine by ourselves. It's able to navigate itself and to run in the solar fields, and also it can drive by the people. Okay, that's my presentation. Okay, thank you, and I'm ready to answer any questions.
Thank you very much, Johnny. Okay, I'm gonna ask you, please, if you can stop sharing your screen so that we can see you and Manuel a little bit better. And we've had a lot of questions, as you can see. There is a team waiting for us, so it's a good thing that we have quite a bit of time. So let's gonna get through them. They're all very specific. I don't know if you had a read, Manuel. By the way, I've turned both of your microphones off so that you can freely talk.
Okay.
So I'm going to start reading, okay? Just going to go through them because there are so many. I had a couple here, but I think let's just go with this. You can also tell that the people in the room know quite a bit because they're very specific. So thanks for your interesting presentation, Manuel. I would like to know how challenging is having accurate information about the solar flux distribution on the receiver for an accurate receiver design and operation, and also the flux distribution not only for a theoretical design point, but during other particular instance of the day. Thank you.
Yes, okay. So first, I just remind that John Cockerill is mainly involved for the solar receiver and, well, the steam generator on the ground, but the heliostat field is out of our scope. So it means that we have to discuss with different heliostat provider and with different kind of technology. And for us, this is also a strength because our system can manage every kind of flux distribution. So we receive, of course, theoretical flux map to validate the design according to the design criteria we have in our software. And at the end, we compare the theory to the reality when the project began truly operational. So, and this is, for example, what we are doing right now in our project in China. And we notice, of course, some difference between, let's say, the real world and the theory. But truly, the ability to make flux map as accurate as possible, it's out of our scope, to be honest.
That's interesting. So who does it? Is it like at the actual plant?
It will be the Heliostat provider because it's a part of DMA strategy. So it's truly related to the let's say the Heliostat science,
Okay.
the optic and so on.
All right.
So we have a lot of interface, and I guess that it makes sense to go to the next question, which is related to the responsibilities between the solar field supplier and the receiver supplier. And the question was, what do we guarantee? Actually, it depends again of the Heliostat provider, but John Cockerill is able to guarantee the power absorbed and the efficiency, the global efficiency of the solar receiver. But sometimes, depending of the Heliostat provider, we could slightly decrease this guarantee if the Heliostat provider would like to take more. But basically, this is it. We do not guarantee the incident power, which is the responsibility of the Heliostat provider, but we guarantee the absorbed power. And I mentioned again that we have a monitoring system with 8 IR camera on the ground and a sophisticated thermodynamic model behind. And we are able to, in real life, in real time, calculate the performances and of course check that we remain below the maximum limitation. So we guarantee the performances in one hand, and in the other hand we guarantee the lifetime thanks to this system.
Those contracts have to be crazy complex.
Yep, the interface is not easy, but as I mentioned, we learn a lot in the process on both sides, I believe, and we found together a solution to have a system very robust, working like that. And because at the end, we have knowledge coming from a lot of different partners.
Okay, this question I'm going to open to the two of you. I'm guessing this is more for you, Manuel, but because the ones at the beginning were for you, and then the ones towards the end are more for Johnny. So,
yep.
What are your thoughts on liquid sodium as a heat transfer fluid in CSP power plants?
Mm-hmm. Yes, this is an interesting heat transfer fluid. Definitely, we are keeping an eye on it. This is clear. We are also analyzing, for example, another heat transfer media such as the heat particles. But yes, there is limitation and it's not so easy to manage. But we have very serious contact regarding sodium to analyze it for the next years.
Manuel, if I may ask, I know this is going to sound like a very silly question probably, but like sodium, isn't the salt sodium as well? So what's different about this compared to like molten salts?
Well, let's say
I know they're nitrates, but
it's liquid sodium. It's a metallic media, and the thermal properties are very interesting, but there is risk associated.
Okay, I'm going to leave it for another webinar then, and we're going to go a lot more into that kind of thing. Okay, what would you say is the most critical moment during the operation of the receiver in a day, and how the design should take care of that? Okay,
so we have to distinguish the normal operation and let's say emergency sequence. So in normal operation, we will have a few moments more tricky, more critical, which are the preheating, because there is no salt inside the receiver. So it's risky in terms of thermal inertia, and you could overheat some parts of the receiver, and this phase is critical because you need to reach at least 250 degrees or a little bit more to be sure that when you will fill the receiver, we will not have any freezing. So yes, I believe that preheating is critical, and of course filling also. And so this is for the normal operation the most critical moment, I believe. The symmetrical moment would be the drainage itself, which will also imply a risk of freezing. And to finish with this question, I would say that in emergency, when we take out the power, well, the heliostat will defocus as quick as possible, but for the first for the first seconds of emergency defocus, we will have a lot of energy, and potentially an issue which leads to decrease the mass flow in the receiver. So basically, if we have this kind of emergency, we need to be able to feed the receiver with salt to cool it down. And yes, this is a very critical scenario we have to analyze very carefully in our solar receiver simulator. And that's it. I don't hear you. I don't know if you speak.
Look at that.
Yeah.
Technical issues. What app do you use for the simulations? Have you ever used SAM to make those simulations?
Yes, actually, SAM is some kind of hybridization, not easy to say it, tool. So it's more for developer, let's say. It's quite a macro analysis. So we use it, and actually we are trying to develop some kind of hybrid tool also in John Cockrell to be able to give a complete answer, not only CSP, but to do an hybrid solution with PV, with CSP, with battery storage, with hydrogen, etc. SAM could do it, but we are also trying to develop something like that. But here, the tool we use are quite more specifics and more accurate, and we will analyze the solar receiver much more in detail that SAM could do it.
Okay, all right. I'm going to let you rest for a little while I go to Johnny for questions for now. But I mean, if there is anything you want to add or answer, go for it. When is the procurement process for Minos is expected to start?
Yes, this project, so we have signed the EPC contract in last November. The EPC is ready to go at any time. And it's still in the progress of finance closing. We expect to start the EPC in the second half of this year. But as you know now, the coronavirus situation, it's a little bit slow down, and the procurement, yeah, we expect to start in the second half, yeah, of this year. Okay. Yeah, waiting for the
second half of this year then.
Mm-hmm.
And just to sell you stuff, they have to call you, right, Johnny?
Yeah.
Get everyone to call you then. Okay, it says here, Quentin says, your tower, I'm guessing is the Linga, is very high for a 50 megawatt plant compared to other projects. Why is this? I don't know. I mean, I haven't compared to other tower sizes, so no idea.
Yeah, I think it's normal. It's the increase the height of the tower, it can increase the efficiency of the solar field. But the height of the Linha project it's normal. And some towers, they are even higher. It's 250, 260. Yeah. I think it's a normal design.
Okay. Yeah. In any case, Gema Solar is also a smaller project. It does have a lot of hours of storage, but it's only 20 megawatts. So
yes, 20 megawatts.
Okay. What shall be the approximate capital cost and operational cost of CSP projects? I'm jumping a few ahead. What shall be the Balaila? He's asking you for project costs, essentially. CapEx and OpEx of per megawatt of CSP projects.
It's a case by case question.
Absolutely.
The different project in different countries, and the capex and the opex is different because the construction cost is different. The labors, the material, the transportation, and but we are seeing the capex and the opex is reducing and going down very quickly. And just many years ago, the capex maybe around for a project over 100 megawatts, and it's around $3,200 US per kilowatt hour. Now it's dropped, yes, less than that. But it's a case by case question. The different project in different countries, the capex and opex is has a big difference. Yeah.
And how do you think you can reach the best LCOE for? Can you like optimize the project for the best LCOE?
Yes, to reach a best LCOE, yes, we have to reduce the capex, opex, and to increase the generation of the electricity. I think the owner, the developer, and also the EPC, they have to design with a best have a best design, because every site has a different conditions of the solar and the solar source and other conditions. You have to use that solar resource and also the land area to maximum the generation, not to waste the energy. First to maximize the generation of electricity. Also for the design, try to be compact and to just reduce some unnecessary design and use some reliable and economic equipment. Equipment is proved to be reliable with the tracking record in the industry, but it's economical to reduce the capex from the equipment side. And for the operation, I think by using some operation tools can reduce the manpower. And yes, also to have a good operation strategy can also helpful to have a competitive OPEX. So yes, I think it connects to the generation, the CAPEX and OPEX. Yeah, it's not very easy.
It depends on many things, essentially. Maybe people can get in touch with you if they have something more specific. There is I've been going through the questions because we have so many open, it's impossible. And there is at least 3 or 4 about cleaning. How often does it need to be done? How much does it cost? How much water do you need? Is the water anything that, people need to be worried about for cleaning of mirrors? Do you want to talk about that? Because also you have smaller heliostat, right?
Yeah. Our heliostat is 20 square meter, and with 4 glasses, each is 5 square meter. And the helio and the cleaning machine is working continuously. And during it can have 2 kinds of cleaning. One is by water, and another is dry cleaning, because in our Berlin site, in the winter, it's very cold. We can't use water, and we use dry clean. but the water cleaning is the result is better. And I think it's a good cleaning machine, and one cubic meter water and can clean around 100 piece of heliostats, and yeah, can save the water cost for the operation.
Okay, I'm going to ask a question to Manuel that I have here. And in the meanwhile, there's so many questions that, Johnny, why don't you take a look and see if you want to answer any specifically, okay? Manuel, the project in Chile, did you need to take specific measures for the seismic design of the tower and the receiver? It's very specific, this question.
Yeah. Yes, of course. Yes. So it has been integrated in the mechanical design, in the anchoring of the solar receiver at the top of the tower. And yes, the seismic conditions were not easy to manage, but as for any kind of building in this condition, we have taken every measure into account. Yes. I'm seeing also a question about
Go for it. Yep.
yes, about
We
the
don't have a lot of
coating.
time, so just answer any questions that you've seen that
Okay,
support.
about the coating. So the question was okay for the theoretical efficiency in labs, but what about real results? And actually, we applied this coating on our site, well, on the project in China. So we will have a feedback quite soon. So I don't have the result right now, but we will know. We will know. This is a coating developed last year, and we have already a reference, and we still need to analyze the results, but we are quite confident. And I have also a question about the corrosion, I believe, about the loop we have built. Actually, this loop will be in operation this summer. And why did we choose to make a new loop? Because molten salt loop are existing in the world, in the market. We did that because we wanted to have something fully representative of our technology, and something very flexible to be able to make sensitivity analysis and truly fine-tune our lifetime model. So it will be a very useful tool, and this loop will be set up just next to our headquarters. So it's like to have a molten salt reference in our garden.
Excellent. Okay. I just wanted to answer to Ruben. He asked how much time has the CSP plan worked continuously, and it's several weeks. We've seen them, and they haven't really been designed to go continuously necessarily, but at times of the year you could manage to, if you design them for it, they could go on, but you can still manage. Johnny, a couple of questions you want to answer, and then we'll call it a day because we have to.
Okay.
And specifically?
Yeah, there are many.
There are so many, it's very hard to manage. Okay, let's see.
Yeah. Maybe from Mr. Huan, he asked me how many people are in the Linha O&M staff. Yes, we have the OM team. They have the several departments: the operation department, maintenance, and I think totally, yes, around 50 people. Yeah, we operate by ourselves. All the people are our own employee. And
in your 50 megawatt plant, how many people do you need?
Around 50 people.
In Spain, that's what it is as well.
Yeah.
So just, can I ask you one of the questions here? Where do you think the biggest cost reductions could come from going forward?
You mean for the CapEx?
Yeah, for CSP, yeah.
Yeah, you mean to just to
Generally, like say for example, Johnny, that tomorrow, next year, you need to sell the plant much cheaper. How do you do that?
Yes, we for our if I show the project, I will see the how much is the ARR and the capex. Yes, for the CSP industry, and we expect it can drop very quickly. And
where exactly? Where does the saving come from?
Now we see, you know, the most of the CSP projects, the tower CSP is in the MENA, in China, in South America, and yeah, they all have the big potential. To
You're not answering my question. Where are the savings coming from? Johnny, you're avoiding it. Is it the components, the turbine, the EPC, the financial package?
Yes, I think that yes, we expect very good news, maybe from Chile. Chile now is very active in the CSP. Yeah, maybe yes, can do a good contribution to the industry. Yeah.
Let's hope so. The Chile has actually announced a 7 gigawatt package as well, which for a small country like that is important. Okay, well, thank you very much, Manuel. Thank you very much, Johnny, for your help today. And thank you very much to all the people who joined us here. And just a last shout for our sponsors who are supporting this content creation and much more for the industry, SQM, provider of solar salts, and Siemens. Thank you very much and see you next time. Bye.
Bye. Thank you.
Bye, guys.